Great. So now the next thing that we're going to do, and just real quick, I actually want to change the canvas's width and height. So what I'm going to do is I'm going to set the canvas width to the document, or the window rather, the window's inner width. I'm going to do that for the height as well. And then for the clear rectangle, I'll set the values that it's clearing to the canvas width and the canvas height, because we want the dimensions to match. See that it's still working? Although our square is very small now. So this brings us now to the meat of our project. We're going to design our game using a very well-known game design pattern called ECS, which stands for Entity Component System Design. And this kind of design is used by modern game developers today. It's used in things as well known as Unity Engine, and it's a tried and true method of scaling your video game. And I'm going to show you how it works. And I'm going to go through each component, no pun intended, of ECS design. The first one we're going to start with is the entity. And I'm going to create a class folder. I'm going to create the entity.js. And in this entity file, we're going to create the entity class. So what is an entity in our game? An entity is it's how it sounds. It's an entity that will have an ID, and this ID is how we're going to attach different components to this object. The entity essentially represents something in our game. So that can be a tile, it can be the player, it can be an enemy, it can be a projectile. It's going to be all of these things. And the way we define whether it's an enemy or it's projectile or a tile is by how we add components to this entity. So the things that this entity is going to have, it's going to have an ID. And this is how we're going to distinguish an entity, distinguish entities from one another. The second thing it's going to have is something called a registry. And I'm going to explain what a registry is in detail, but for now, let's just add this to our entity. And last but not least, we're going to have this components. And this components is going to start off as an empty object. And this segues nicely into what a component is. So I briefly touched upon that, and let me actually rename this to classes, because we're going to have multiple classes in here. So now let's create our component class. So what our component is, it's essentially a grouping of a specific kind of data. It sounds abstract, I know. However, it'll all make sense as I go along. So the one thing it's going to have is component type. Let's assign component type to the parameter that's being passed in. And component type is going to be a string. So component is a kind of data. It's very abstract. So give me a specific example, right? You probably want something more concrete. So the first component we're going to make is a position component. And if you think about it as a grouping of data, what is position in our game? Position is going to be defined by two values, an X value and a Y value. This is the kind of data grouping I was talking about. So let me show you how this looks. It's going to take the component type and a component object, which is going to contain the parameters of X and Y, for example. So we're going to call this super because it's extending this original component, and this takes a component type. So we need to pass it from the constructor to the super, which might not be something, if you're not familiar with how classes work in JavaScript, this is how we satisfy dependencies from inherited classes. Then we're going to set this X, so a position component will have an X part, and we're going to take it from the component object We're going to have a Y. And what else could position have? Well, not necessarily, but I like to think about position not as just an X and a Y, but also the width and the height of the entity. Because not only, it's not just one point in space, it actually takes up an area, and an area includes width and height. So this width is equal to component object width, and this height is equal to component object height. And you're going to see when we pass in, or when we create a position component, we'll be passing in an object that will look like this. It's going to be something like this. X, and I'm just making up numbers, but it's going to look like... And from there, these values are going to be populated from the component object that we're passing in. So I hope that's now starting to make sense. What are some other data groupings, components, that are relevant in our current example of the square? Well, one that comes to mind for me is movement or velocity. So our position is going to be changed by the velocity that the entity has. So let's make a component that contains the data for the X velocity and the Y velocity. So I'm going to call this class movement component. It's going to extend component, and it's going to follow a similar pattern as our friend up here. Call the super. And what goes into the movement component? Well, as I just mentioned, the X velocity and the Y velocity. So let's actually just call this Vx, velocity X, is equal to component object Vx. This Vy is equal to component object Vy. Now, something else to think about is there will also be collision a little bit later. So Link, as a player, he's not going to just be able to run over objects that he shouldn't be able to run over. He's going to be able to, he has to run into walls. Maybe he has to run into to enemies. He might run into the lake and he can't proceed past the water's edge. There's going to be things like that that we need to think about. So I might be getting a little bit ahead of ourselves, but something I do want to add is there's going to be collision properties as well. So collision X, and we're going to just give this default value of false, because when Link is created, he's placed on the screen. He won't be colliding with anything because he will be put just right into the map. And he's going to be a collision Y as well. Great, so now we have our entity. It's a kind of object that holds certain kinds of data. How do we actually have this data affect what goes on screen? We need this data to interact with one another, right? Like the movement component is going to need to affect the position component. So how do we do that? Well, how we do that is through the use of systems, and that's the last part of ECS, Entity Component System Design. We have a system. These systems will be concerned with specific kinds of data. So let's create a system class. And the first system that I want to create is the movement system, since that's something that we're already doing with our game. First, I'm going to define a system, because we're going to have a base class, and you'll see why we need this later. It's going to take, similar to the component, a system type. So this is just a string. So this system type is equal to system type. We're going to have a variable, or a property of the class, I should say, called thisEntities. It's going to be equal to an empty array. Each system is going to have a certain number of entities that it concerns itself with. And we're going to determine what those entities are based on the components that they have. So for example, let me create my movement system, not movement component. This is going to take system type because it's going to be used in the super. There we go. So And this movement system is going to be concerned with entities that have components of component requirements of movement and position. Because if you think about it, there's going to be a lot of entities that don't move. So for example, the tiles that Link walks on, you know, the background sprites that you can't really interact with, the movement system doesn't need to interact with them because they don't move. We don't intend for them to ever move. They are where we place them to be. And we will be interacting with the entities that we're concerned with by using this update function. We're going to loop through all the entities, and we're going to do two things. First, we're going to get the specific entity, just because I like to do that. Let's get the movement and position component from the entities components. And then to keep it simple for right now, all we're going to do is do position x plus minus, or excuse me, plus movement vx, position y, movement vy. And that's going to be it for a very simple system. Although this is the beginning, and this system will be more complicated by the end of this, and we're going to have probably over a dozen systems by the time we're done. But this is the ECS design in action. Now, the last part of the ECS architecture design that's not in the name is the registry. What the registry does is it coordinates between the systems and the components, and it adds systems to the game, and it also will remove systems from the game. It'll add entities to systems. It'll remove entities from systems. So it's kind of like the conductor of the orchestra, and it makes sure all the pieces are working properly together. We're going to code this out right now. So the last class is the registry class. Let's start off by creating registry class. The constructor. So our registry class isn't actually going to take anything. All of the properties are going to be default properties, at least the properties it starts off with. So the first thing we want to do is this registry is going to use the number of entities that exist in order to assign an entity's ID to it. So if you remember before, we wrote ID right here. This ID is going to be passed in from the registry based on when it is created. So every time we create an entity, this number is going to be incremented. Since in programming, you typically start at 0, the very first entity that we create, the square, for example, is going to have the number 0 as its ID. Now, if we were to create a second square, the second square's ID would be 1, and so on and so forth. The next property that we have is the property of systems, and this is where the systems are going to live. So the registry is going to have all of the systems in this object to be able to keep track of it and to access them quickly. So next, let's create the create entity function. So the create entity function is going to look like this. So you're going to see in a little bit that from the game class, we're going to create an entity, and from this file, we're going to pass specific components. To start with, we'll create a new entity. We're going to set it equal to the object or the class. And I actually forgot, I need to export all of these classes. So let me do that right now. I don't think we're going to need these, the parent classes of component and system. Export movement system. Fantastic. Okay. Perfect. And the things that we're going to pass into it is this number of entities. We're going to increment it right after it's passed. And we're also, if you remember, it wants to have a copy of registry because we're going to be using this later. So I'm going to pass by reference this. And this refers to the instantiation of the registry class. Next, let's get ready to add our new entity components. As I go, I like to code and make my code very verbose so you know exactly what the variable is. So let's add these new entity components. How do we do that? Well, we're going to pass into create entity this variable or this parameter of components. And what is components? Well, components, this variable, or this parameter is going to be a string, an array of strings. So for example, it'll look like something like movement. That's what we can expect to see from this argument. So for I is equal to 0, I is less than components length, increment I. So now for each component, let's go through and see which component it is that we're receiving. Now we haven't thought about this yet, but we need a way to differentiate one component from the other. So we need to know that it's a movement component instead of a position component and vice versa. But now that I say it out loud, we also need to know what kind of values it's going to be passing. So we might want to instantiate one entity at x300, y400, and another entity at x0, y10. So actually, this array of strings will not work. You know what we need? We need an object that has a certain kind of structure, an object that can denote if it's movement, and then also carry the data along with it. So we're going to pass in, when we do use this function, we're going to pass in a string. So we'll just call this the name of the component, like movement. And then we're going to pass in the value, or the values that it may have. So it'll have Vx, 0, Vy, 1 or 0, whatever. I think that's actually a better way to do this. So it's going to be an array of objects, not an array of strings. So now that we know we're going to be passing create entity an object like this, let's use a switch case for component name actually. And if the value is equal to position, then we'll create a component object just like here. Remember, we use component object, and we're going to set it to the value. So actually, I'm going to just change this example right here. If this was position, so it illustrates it better for you. X, Y, height, width. Okay. So we're going to set it to this value because this matches this. Okay. So component value. And then we're going to add this into the new entity components. And we're going to set the name of it to position. And we're going to create this new position component by passing the name, because component is expecting the component type right here, which will be used by the system here. Do you see how this is lining up? And we're going to be passing the component object itself. Next, we're going to create the movement component. We're going to follow the same pattern. So component value. Oh, you know what? I have to add brackets because they can't exist in the same scope. That's fine. There we go. And we're going to do new entity components is for movement. Is equal to new movement component. Component name and component object. Let me move this over a little bit so we can see this clearly. That's better. Then at the end of all of this, we're going to have our new entity components, our new entity components, and we're going to set it equal to new entity components. Then we're going to need to add these newly created entities to this system. And I just realized we need another array in the constructor that will hold the entities that need to be added. So this entities to be added is equal to empty array. And I'm going to push this new entity into the array. Next, we're going to add a system to this system's object. So I'm going to add the system. And this is going to take a system type. Because, and I just keep going back to this to reinforce it. When we create a system, we're taking a system type, right? So we need to pass it a system type here, okay? The reason why we have system types is because later, and in a little bit you're going to see, we're going to get a system by the string that you pass to this constructor, and we need it because there's no other way to get the system if we don't have some kind of uniquely identifying string. While I'm creating the system, I'm going to just set up a variable for it, so new system, and I'm going to just leave it undefined at the moment. And I'm going to set up a switch case for the system type. So right now, the only system that we have is the movement system. So the case is going to be movement system. I'm just going to set up the default right now. Okay, so if the system type is the movement system, then we're going to want to set the new system to movement system. We're going to create or instantiate an object from the movement system class. I'm going to import it as well. So now it's up here. And we're going to pass it this system type string. Movement. Okay. Now that we have that set up, I'm going to do this systems and I'm going to put it into the object using the system type string as the key and then the new system as the value of the key value pair. And we don't need to return the system, at least not yet. So we can just leave it like that. Cool. So I know we did a lot, but before we actually bring it all together, I want to show you that it's working so that way we can stay on the same page. Let's go to index.js. And I'm going to initialize this registry to undefined. Registry, and I need to import. Actually, first I need to export registry. There we go. You know what? I can even set it up in the constructor. That's fine. Now I want to add the registry, or excuse me, I want to add the system that we just created, the movement system, to the registry's this systems property. So how do I do that? So let's do this registry, add system, movement system, and then let's console log this registry systems. Let's see if it's working. Let's see, I'm getting an error. Cannot get classes registry.js. That's because I don't have the JS extension at the end. Seems I'm still getting that error. Let's see where it's going wrong. There we go. So it did work. Sometimes you just need to reload it completely. Failed to load resource. The server responded with the status of 404 not found. Okay, so if you're getting this error, I want to be very clear with you guys, and I thought that my my text editor would help me with this. You need to specify the ending of the file. So the reason why it's erroring right here is because it can't find the file. Even though it might be pointing to the right place, the main issue is that it doesn't have the file extension, so it doesn't recognize what that means. So if I do this, cool. Now I'm getting another error. This is not defined a game initialize. There we go. I'm able to put the movement system into this system. That's good. That's a really good first step. And it has the two component requirements, movement and position. That's great. Now we need to get the entity that we create into the movement system. So I'm going to just do this right here. This registry create entity. Before that, remember how we said we're going to set up properties that are just like this? So I'm actually going to create a dummy position component. Okay. And then I'm going to create a dummy movement component. Cool. And it takes an array of objects. Let me just put them in here right now. Doesn't matter the order. And if this worked, I should be able to just console.log out the entities to be added, and it appears right here. This is our entity with the two components that we specified, right? And it has the values that I put in as well too. Watch, if I change this to 2 in the position component, it has 2. So boom, we know that it's working. Very good. Now we need to get this entity into the movement system. And we're going to do that, or rather our friend the registry is going to do that by adding an entity to the system, or adding entity to system. So now what's going to happen, for every entity that's created, we're going to loop through this array right here. And for every entity, we're going to check its components against the component requirements of every system that the registry has. And if they match, then we're going to add the entity into the system. So since our system's property in the array is an object, we need to do something a little bit different to loop through them properly, or at least to loop through them in a way that makes that isn't too big of a pain in the butt. So I'm going to use the object.values method from JavaScript, and then I'm going to go for each system. So if you console.log out system, we're currently not calling this method, but let me just show you what this looks like. I'll take this for right now. If you console.log out the system, we get the object, okay? So this system is equal to an object that has entities array, component requirements, and system type, movement system. And then it has whatever functions that we give to a system. Every system that we're going to make pretty much will have an update. There's going to be a few systems in the future that we're going to make that have other methods. We're going to get to that later, but just so you know. So now that we're going through each system, let's loop through, or let's just get the component requirements. And how I want to do this is I want to go through each component requirement. And if the entity, and then we're going to loop through the entity. And if the entity does not have the required component, then we're going to just set it to false. We're going to break the loop, and we know that we do not need to add this entity into the system. In order for an entity to be added to the system, it needs to have every single one of the components that are required. So I can actually just create a variable. It'll just be a Boolean flag. So I can do add to system equal to true. And then once we encounter that, we can set it to false. It'll be easy to change. And we're going to locate, or excuse me, we're going to go through the component requirements. And you know what? Actually, I'm going to get the component requirements right off the bat from the system and component requirements. And now we're going to go through these component requirements one by one. I'm going to make this bigger again, so that way we can easily see what it is I'm doing. We're going to set, okay, const requirement or equal to the component requirements. So now we're going to get the individual requirements. So that's going to say something like position or movement. So if the entity component's requirement is equal to undefined, meaning it does not exist, we're going to just set the add to system equal to false, and then we're going to break the loop. The reason why this works is that, let's take movement, for example. This movement requirement is going to be the same exact value. It's going to be a string of movement. And this will match up with the component type here, because this will also say movement. So the entity, for example, its components are going to look something like this. Movement, position. Now, if it doesn't have movement, let's say it doesn't, it won't find it here. It's just going to see position. So it's going to be like, where's movement? Oh, movement doesn't exist? Then this cannot be a match for the system. So let's break. At the end of cycling through all the components, if there was never a mismatch with the component requirements, meaning every component that it needed to have was in there, then if it's still true, we're going to push the specific system. We're going to push it into the entities array that each system has. And now it's in the system. So let's see this in action. So if we go to our browser, let's go to the console. And if you console.log this registry, Keep on capitalizing things that do not need to be capitalized. Systems. Now we go to the movement system. It has our one entity. So it means it's properly getting entered into the system. Okay, but let's just make sure now that this isn't just by chance, right? So let's actually just get rid of one of these components, because theoretically, if one of the requirements is undefined, then this shouldn't be able to get into the system. So let's just be doubly sure right now, right? It's not there. So we made it correctly. If you've been following along and you're running into problems, go over this. I know this is kind of a lot of information. It took a little time for me to get the hang of the ECS pattern. It is a bit complicated, but just hang in there. It really is a super powerful technique. As I mentioned before, game engines like Unity uses this kind of design structure. It's really worthwhile learning. These are skills that will take you anywhere you want to go. If you want to do game development, hell, you could even get a job and put this on your resume after you're done doing this video series. I think it's time to actually make it do something based on user input. So let's go to the system.js file, and we see that it's updating the position X and position Y. So let's just make sure that this is working. We're going to set this to 10 and 10. Oh, and I almost forgot. So we need to actually use the system in our game. So you may have noticed that we have an update function, and we also at the same time have an update function in our game. So we're going to actually call this update function from this update function. That sounds really easy, but okay, how do we do that? So what we're going to do is, again, we're going to use our good friend, the registry, and we're going to get this system using a method. And we could code it out just using some vanilla JavaScript, although this tends to be a better OOP pattern to use getters. So I'm going to use get system is equal to system type, and we're just going to return this system's system type. So in here, then we do this registry, get system, and the system that we're getting is the movement system. Cool. So once we get it, what do we want to do with it? So this call is equivalent to the movement system. So why don't we just directly call the method, the update method. And if we did it properly, oh, apparently we did not do it 100% properly. This entities is not defined. Ah. So the issue was I didn't write this. Okay, there we go. So now let's just make sure, no other problems. Cool. Okay, so we're seeing that it is incrementing the position X. It's not incrementing Y because I capitalized Y, of course. Boom. Cool. So now that we see the system is properly updating values. So the next thing that we want to do is we want to change the screen based on the data changing. So how we're going to do that is we're going to make a third system, rather a second system using the main system class. And we're going to make a system that's called render system. And render system's job is going to be to render the entities on the screen. And it's going to take the entity's position And based on that position, it will draw an object, or it'll draw a square, it'll draw a sprite, it'll do those things. The render system is going to take over some of this context stuff. Extend system. We're going to be using context in the render system. So constructor. It follows the pattern of the previous system. So it has system type as an argument. System, this component's requirements. And later, and we'll just put position now as the only requirement because a thing doesn't necessarily need to be able to move for it to be rendered. Later, we're going to have a sprite component, and that will be part of the component requirements for render system. We're going to write its update method, where it will update the screen. And we're going to put context and the canvas. We're going to make it accessible to the render system. So let's go to the index.js. And I'm actually going to export these things. Remember, I mentioned that these would be global variables. And we're going to take this. We're going to put it into the update function. Make sure we import it from the index.js file. Context and canvas. We can get rid of the player destructuring. And let's just add in dummy properties right now for X, Y, and width. We will come back to these in a little bit, but I just want to show you that it's working. Let's add this into the registry. We need to make this a system that can be added to the game. So we'll export render system. And then we will add this to the switch case. Render system. Oop. New system equals new render system. System type. Just make sure it's being properly imported. Yes, it is. Oh, almost forgot I need to call the super right here. System type. There we go. Then in index.js, let's add this system. This registry add system. Render system. And let's call that update function. So this registry get system. Registry system. Oh, excuse me. Render system, not registry. Render system. Going to update it. And let's go back to our screen. Okay, the square is still there. Let's just make sure console.log in render system. Yep. Okay, cool. So the render system is properly being created and then being called. Now let's take a look at the entities in the render system. Okay, let's just make sure. So our entity that we created is in the render system. Now keep in mind though that one entity can be part of multiple systems. So our entity can belong to both the movement system and the render system. So now what we want to do is we want to go through all of the entities in the render system, and we want to update where the square is being drawn based on where the entity is. And we know where the entity is based on its X and its Y value. So what we do is we do for let equal I. We do the typical JavaScript for loop. Let's just get the position of this entity's I. So position. And actually, we can destructure this again. Const X, Y, width, height is equal to position, X, Y. Let's go to our browser. Cannot destructure property X of position as it is undefined. Oh, that's because I did not go into the component properties or the components properties. And also now we need to fill the rectangle based on the position and the width and the height of our entity. Oh, that looks kind of cool, but it's not exactly what we want. We need to do this based on canvas height, or excuse me, canvas width, canvas height, and we need to start from 0. That was my mistake. Because we need to clear the entire canvas. This is clearing the entire canvas, removing all images, all text, all sprites, etc. from the canvas, from the previous frame. And then this is filling the specific area with whatever the fill style is, the specific area of the entity. Let's go back. Cool. Wow, it's a fast little square. Nice. Now it's moving from left to right. Perfect. Now we're going to change the X and Y velocity based on the user input. So first off, we want to create an entity. We want to create the player, and we need to change him from just being some square with X, Y, and height and width values to being that entity. So we're going to delete this, and we're going to just simply set this dot player equal to this creation, this the return value of the create entity. Replace this. And let's now take a look. We're going to keep that. And where the player's velocity is just 10, we're going to set it to 0. And we're going to set the player's velocity here. What I'm actually going to do is I'm going to just movement component, player movement component. I'm going to replace these player movement component. Let's see now if it responds. The problem is you hold a button in one direction and it just continually increments the velocity. The velocity isn't slowed down when you release the key. So that was actually what I was referring to before about having a key up event. When we release the key, we want the velocity for the specific direction to be 0. We don't want to slide like this. We don't want to maintain velocity from a previous key press. So let's go back. And now we're going to add our type key up. Let's do another, and actually let's just pull this up here so it's in scope of the other else statement. So switch key. So right here, we're going to set the velocity of W and of S to 0. And then we're going to set the velocity of A and D to 0. A and D are x-axis, W and S are y-axis. So if the key is W, and be careful of the JavaScript syntax when it comes to this, because this is how you need to write it. If it's either W or S, the player movement component .vy will be set to 0. And if it's A or D, we'll set the player movement component Vx to 0. Let's put brackets around these. Let's see what we got. Cool. And as we see, if we press D, it goes to the right, and then it stops on my fingers off the button. I press A, W, S. So now we've completed the movement system and the render system, and the movement system is properly updating the player component's position based on its movement, and we're updating the movement component from the user input.